Can loss functions improve PyTorch machine learning models? Have you ever wondered how machine learning models learn from their mistakes? One key element in this learning process is the loss function. So, can loss functions improve PyTorch machine learning models? Let's find out together. Loss functions are essential in the training of machine learning models. They provide a way to measure how well the model's predictions align with the actual outcomes. When training a model, the loss function calculates the difference between what the model predicts and what the true values are. This difference is expressed as a single number, known as the loss value. The goal is to minimize this loss value over time to improve the model's accuracy. In PyTorch, there are various types of loss functions tailored to different tasks. For instance, if you are working on a regression task, you might use mean-squared error. This loss function calculates the average of the squared differences between predicted and actual values. It emphasizes larger errors, making it useful for tasks like predicting prices or ages. Alternatively, mean absolute error measures the average absolute differences and is more robust against outliers. On the other hand, if your task involves classification, you would likely use cross-entropy loss. This function compares the predicted probability distributions with the actual class labels. It is particularly effective when identifying categories, such as distinguishing between images of cats and dogs. For tasks where relative ordering is important, such as recommendation systems, ranking loss functions come into play. These functions assess the distances or similarities between data points to ensure that the model understands the importance of order. PyTorch's neural network module, known as NN, includes a variety of built-in loss functions that can be easily integrated into your training pipeline. By selecting the right loss function that matches your specific problem and data, you can provide meaningful feedback to the model during training. This feedback is vital for the model to learn and recognize useful patterns. From the perspective of artificial intelligence development, choosing the right loss function is not just a technical decision. It also has ethical implications. For example, in sensitive applications like medical diagnosis or content moderation, the choice of loss function can impact model fairness and reliability. An inappropriate loss function might lead to biased outputs or underperformance on minority classes, raising ethical concerns. Additionally, productivity plugins and tools designed for PyTorch development often come with features that assist in selecting and configuring loss functions. This makes it easier for developers to experiment and optimize their models effectively. In summary, loss functions are fundamental in improving the performance of PyTorch machine learning models. By understanding and using them correctly, developers can create more accurate and reliable artificial intelligence systems.